It's okay. In this problem, it says the light metal storage building shown in figure 1, which again is just a one-story building, picture of one-story building, doesn't really add to the problem, except for helping you visualize the building, the exact building, uh, is on open flat terrain where V is 113 miles per hour. The side wall of the building is 14 feet high. The roof is essentially flat. Building is fully enclosed. So, we're asked to determine KZ. Oh, for low-lying obstructions. So, if, let's just say we're given V equals 113 mph, in our equation, 0.00256, that would be KZ, KZT, KD, KE, V squared. We can take this open flat terrain with a direct wind direction, and because we know that it's fully enclosed, it actually just tells us to say that KE equals 1. So again, we're left with KZ and V squared, and we know that 113 squared is 12,769, so let's multiply that by 0.00256, and what we're left with is 32.68 kz. This is what qz or qh equals. I don't actually know the difference between qz and qh off the top of my head. Pretty much the same, but they're used differently, so watch out. QH is like the height at any certain point. QZ is like the height of the building, I'm assuming. So, side wall is 14 feet high. So it's between 0 and 15, so I'm thinking that we're going to need to, well, no, because it's between 0 and 15, it's just going to be 0.85. So this KZ here is actually going to be 0.85. So that means that QH slash QZ is going to be equal to 27.78. Sweet. Equals QH. So now that we know QH, we need to find P. P equals Q times G times the internal pressure minus QH times G times CPI, but I'm pretty sure that's plus or minus. So now, as we remember that for a fully enclosed building, this is going to be 0.18, and open flat terrain, this is going to be 0.85. And because this is not a windward wall, Q is actually equal to QH. So with all of this, I think we really just need to find that number there. Because essentially we have P equals 27.7, 0.85 internal pressure minus, well, this 27.7 times 0.18 is 5. Pretty much, this is going to be plus or minus 5. It's like 0.001, but I'm just going to say it's pretty much going to be rounded to 5, and it won't make too much of a difference. So, what is going to be our pressure coefficient? Let's look at tables. Right? Doesn't say it here? No. So let's come here to loads. Go down to wind loads. For a leeward wall, we need to find L over B. Do we have L over B? Do we have that at all? We know it's 14 feet high. That's all we know. And is it asking for sidewall? I'm going to make sure it's not asking for a sidewall. What are the two values of designed wind pressure acting on this wall when the wind blows on the back of the building? Let me make sure it's not asking for sidewall. The light metal storage building shown in figure 1 is on open flat terrain where V equals the sidewall of the building is 14 feet high. Okay. If we're just given, here's something you'll learn the hard way. If you're just given the height and you don't know the L over B, it's probably going to be the sidewall because you don't need the L over B for the sidewall. So for sidewalls, all values are going to be negative 0.7. So coming back into here, we can now replace this with negative 0.7, which is going to give us two p values, p equals and p equals, and they're both going to be negative. So now 27.78 times 0.85 times negative 0.7. We're going to add 5. And it's going to be negative 11.53. And we're going to do the same thing, but we're going to subtract 5. Negative 21.53. I'm hoping that I don't have any rounding errors and that this should just work all good. Negative 11.53, comma, negative 21.53. There we go.